Hi everyone. In this video we're going to look at sketching subsets of the complex plane. So these graphs are going to tend to work out to be either circles or straight lines. I don't know if we really encounter many other than that. So that's what we should expect to do for the most part. Now I'm going to go through this question. I'm going to show two different ways of doing it. It's going to be up to you to decide which one you prefer. I think one way of looking at it is much more just logical, and the other is much more algebraic, and you can actually go through and sort of prove that something is the way that it is. So first things first, I want to look at this equation, and I've got the modulus of z plus 1. Now, if we think about our other graphs that we've encountered before, when an equation is in this form, we can read off the translations. So what I can say about this graph is that it is translated 1 unit in the negative direction of the real axis. So this plus 1 here translates it 1 unit to the left. Okay, and now the other thing is that we're doing the modulus here. So the modulus is a measure of the distance from a particular point, and we can see that the modulus here is equal to 2. So that means that every point that we draw has to have a distance of 2 from wherever our sort of starting point of this graph is. And so I can draw this fairly quickly and easily. So there's the imaginary component. And the real component. And the graph is moved 1 unit to the left. So that's essentially the middle point of the graph, and then every other point has to be 2 units away from that. So for that to happen, we're going to essentially have a circle formed around this point with a radius of 2. So I know that's going to go through there, and it's going to go through there, and it's going to go through there, and through there. And so if I try to draw this now, please just bear with me, the circle's not going to be perfect, but it shouldn't be too bad. There we have it. And I can label these sort of endpoints of the circle. So this one here is 1 plus 0i. This is negative 1 plus 2i. This is negative 3 plus 0i. And negative 1 minus 2i. And, well, there we have it. So that's a very logical way of arriving at that answer. Now, another way to do it would be to say that, well, z is x plus yi. So what I've really got there is the modulus of x plus yi plus 1 equaling 2. If I just group the real and imaginary components there, I've got modulus of x plus 1 plus yi equaling 2. So that means the square root of x plus 1 squared plus y squared is equal to 2. And I can square both sides to get x plus 1 squared plus y squared equals 4. So this is the equation of a circle, which is translated 1 unit to the left because of the x plus 1 squared in brackets. It has no vertical translation because there's no plus or minus anything after the y, and it has a radius of 2 because we know that the equation of a circle is x squared plus y squared equals r squared. So that's another way that you could go about figuring it out. And then again, just a matter of drawing it onto the graph. So that's all I'll do for this video. I'll leave it there and pick up with some more examples in the following videos. See you then.